benar-benar sayang pada dirimu, kasihku. Janganlah engkau ragu pada diriku. Daku berkelana mencari harapan yang kita impikan, dari terbitnya sang surya hingga tenggelam.
Hello everyone, today we will be explaining Metallocene catalyst. In this video, we will cover the manufacturing process, raw material process condition, major equipment use, economic, environmental, and also the reaction mechanism involved. Let me start with a brief introduction first. Metallocene catalysts are advanced organometallic compounds used in mainly the polymer industry compared to conventional catalysts. Metallocene catalysts allow very precisely control over polymer structure. Because of this, they are widely used in the produce high-performance plastic with improvement, strength, clarity, and consistency.
Now, I will explain the manufacturing process of Metallocene catalysts. The production starts with the preparation of organic ligands using cyclopentadiene-based ligands. These ligands plays an important role in stabilizing the metal center and controlling the catalyst performance. This step is carried out carefully to ensure high purity as impurities and can affect catalyst activity.
Next, after the ligands are prepared, the next step is the formation of the Metallocene complex. In this stage, the organic ligands react with a transition metal compound, such as zirconium or titanium, in an organic solvent like toluene. This reaction is conducted in an inert atmosphere using nitrogen or argon to prevent any reaction with oxygen or moisture. The result is a stable Metallocene metal complex.
Once the Metallocene complex is formed, it must be at least before use. A catalyst commonly used MAO is added to activate the metal center. After extraction, the catalyst is purified through refrigeration and solvent removal. Finally, the Metallocene catalyst is stored in sealed container under the humid conditions to maintain its activity until it is used in polymerization.
Next, I will discuss the raw materials involved in the manufacture of Metallocene catalysts. The key raw materials include transition metals such as zirconium or titanium, which act as the active metal center. Organic cyclopentadiene ligands are used to stabilize the behavior. A co-catalyst using methyl alkylate is required to activate the catalyst. In addition, organic solvents such as toluene or hexane are used as reaction media, while inert gases like nitrogen or argon are used to maintain an oxygen-free environment.
Now, let's look at the process conditions. Metallocene catalyst synthesis is performed under relatively mild conditions. The temperature is typically maintained between 20 and 80 degrees Celsius, depending on the specific catalyst formulation. The pressure is usually atmospheric. However, strict control of moisture and oxygen levels is essential because Metallocene catalysts are highly sensitive and can easily deactivate if exposed to air or water.
Moving on to the major equipment used in the manufacturing process. The production requires inert atmosphere reactors, which are usually glass inert and stainless steel reactors. These reactors are equipped with agitation system to ensure uniform mixing. Filtration units are used to separate the catalyst product, while solvent recovery and reaction system help recycle organic solvent. Analytical instruments such as NMR and gas chromatography are used for quality control, and seal storage vessels are used to store the catalyst safely. Now, let's discuss the economics of the Metallocene catalyst process. One of the main factors affecting the cost is the raw material transition methods such as zirconium and titanium are expensive, not widely available. In addition, the organic units and catalysts used in the process are also costly and require fiber, which increase the overall production cost.
Besides raw materials, the production process itself is also expensive. The manufacturing requires specialized equipment, aided atmosphere system, and strict quality control. Skilled operators and advanced analytical instruments are needed to ensure catalyst performance. All these factors contribute to high operational and maintenance costs.
Despite the high production costs, Metallocene catalysts are economically attractive. They enable the production of their high-performance polymers with superior quality, which can be sold at a higher price. This added value helps offset the high manufacturing costs and makes Metallocene catalysts commercially viable in industries such as packaging, automotive, and medical applications.
Now, I will discuss the environmental and sustainability issues. One major concern is the use of organic solvent, which may contribute to volatile organic compound emissions. Other issue is the generation of organometric waste, a STEM catalyst. To improve sustainability, industry focus on solvent recycling, proper waste management, and the development of more environmental-friendly catalyst systems.
Next, let's look at the uses of Metallocene catalysts. They are primarily used in the polymerization of olefins such as ethylene, propylene to produce polyethylene and polypropylene. These polymers are used in applications such as packaging films, automotive components, medical devices, and high-quality consumer products. The precise control offered by Metallocene catalysts allows manufacturers to tailor polymer properties according to the specific applications.
Now, let's look at the reaction mechanism involved. First, the metallocene catalyst is activated by a co-catalyst, usually metallocene or MAO. This activation step creates an active metal center that is ready to interact with the monomer.
After activation, the olefin monomers such as ethylene or propylene coordinates to the metal center. The double bond of the monomer interacts with the metal, positioning it correctly to the next step in the reaction. In the final step, the monomer insert into the metal-carbon bond through a coordination insertion mechanism. This process repeats continuously, leading to polymerase grow with the uniform structure and control properties. In conclusion, Metallocene catalysts are important specialty chemicals that play a key role in modern polymer production. Their control synthesis, high efficiency, and ability to produce high-performance material make them valuable despite their higher cost and environmental challenge. Thank you for listening. Bye.